So so we will going to start with different understanding differential equation. Before starting with the differential equation, what do you mean by equation? Equation means something in some algebraic expression where you have equal to sign, that is called equation. Okay, so what all equations we have studied? We have studied equation like x is equal to 2. We have also studied equation like x square, okay, minus 4 is equal to 0. Okay, this is called linear equation, this is called quadratic equation. Similarly, we also studied x cube, okay, plus say 2x minus 8 is equal to 0. So, okay, all these equation, this is called linear equation, this is called quadratic equation, and this is called cubic equation. Why we are calling this as linear equation? Because power of x is 1. Why we are calling this as quadratic equation? Because power of variable x, that is 2. Why we are calling this as cubic equation? Because the power of x is 3. Okay, you have also studied the equation called sine square x plus cos square x is equal to 1. This is a identity, right? This is also a kind of equation. This also you have studied. What is this equation called? This equation is called trigonometric equation. Why? Because here you have trigonometric function. Okay, similarly, instead of this, if you have derivative involved in some equation, for example, say you have dy by dx is equal to say 5. So this is what, this is again is a equation. Why? Because this is a equal to sign is there, so it is a equation. Now what is the name of such equation? The name of this equation is differential equation. Why it is a differential equation? Because you have derivative involved here. How many different kinds of differential equation you can have? You can have differential equation like say d2y by dx square is equal to 0. Okay, dy by dx is equal to 0. You can even have d3x by dx cube is equal to 0. Okay, you can even have combination of this like x dy by dx plus y is equal to 0. So this is all we have already studied earlier in differential chapter and application of differential chapter, that is on equation, that is chapter number 1 and chapter number 2. Okay, so you can even have some other differential equation like x d square y by dx square, okay, plus say you can have y dy by dx is equal to 0, or you can even have like say x d2y by dx square plus y is equal to 0. So this is one kind of differential equation, this is another 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 kind of differential equation. The reason why I'm saying this is as differential equation, because this involved derivative. Okay, this involves derivative, that's the reason we are calling this as differential equation. Now you can even have, instead of x you can have t, instead of x you can have theta also, it's perfectly okay. Okay, you can write this as say in polar coordinate, you can even write this as r of dr upon d theta, okay, minus cos of theta is equal to say 8. This is again a different form of differential equation in polar coordinate. Why I'm calling this as polar system? Because here r is there and angle theta is there. So this is again a form of differential equation. Clear? Fine. So that's what is written here. Equation which contains the derivative of a function is called a differential equation. The following are differential equations like dy by dx is equal to cos x is a differential equation. Then d2y by dx square plus k square y is equal to 0, where k is a constant. Okay. Then again here d2w upon dx square minus x square dw by dx plus y plus w is equal to 0. Then again d2y by dt square plus d square d2x by dt square is equal to x. Here x and y are the function of t. Okay. And here it is say d3y upon dx cube plus x dy by dx minus 4xy is equal to 0. Here again x is a function of y. Okay. Here r dr by d theta plus d theta is equal plus cos theta is equal to 5. This is again a different form of differential equation. Here r and r is a function which is differentiable with theta. And what is that theta? Theta is an angle measured in radian. Okay, so the next point is what? Order and degree of differential equation. So to understand this better, let's go to our 9th standard or maybe 10th standard. We have a say a polynomial or equation like say x square y plus x y cube plus x to the power of 5 y square plus say xy plus x square plus y to the power of 4, okay, is equal to say some number 50. Now this is a polynomial, or you can say this is a algebraic expression. So in algebraic expression we have a concept called what? We have a concept of order, not order, we have a concept of degree. We have a concept of degree in this algebraic expression. So can you tell me what is the degree of this algebraic expression? The degree of this algebraic expression will be, over here the degree is 3, over here the degree is 4, over here the degree is 5, over here degree is 2, over here it is 2, over here it is 4. So what is the degree of this entire this? It is 7. Okay, we will going to consider only this particular degree. Similar concept we have in differential equation also. So what it says, we have the two concept over here. One is called order of the order and second is degree. Now let's understand what is order and what is degree. The order of a differential equation is the highest order of the derivative appearing in the equation. Let's understand this one statement with some example. Say you have dy by dx, this is first order derivative. Then you can have d square by dx square, this is your second order of derivative. Then you can have d3y upon dx square plus xy d2y by dx square, say dy by dx is equal to say x. This is your third order derivative. You understood this, right? How many times you are taking the derivative, how many times you are differentiating the y with respect to x, that is called order. Okay, this we have already studied in previous chapter also. Now what we have not studied is this degree. Now degree of the differential equation is the power of the highest order derivative present in the equation. So I can even have my derivative or this differential equation like this. How? d2y upon dx square whole to the power of 2 plus d3y dx cube. Okay, then you can also have plus dy dx plus y plus x is equal to say 0. Okay, now here I will going to ask you one question. What is the highest order in this particular differential equation? So the highest order, okay, the highest order in this particular equation will be 3. Okay, so I will say order of this differential equation as 3. Now next term what we have is degree. Can you tell me what is the degree of this differential equation? After reading this particular statement, the degree of differential equation is the power of the highest order derivative present in the equation. So highest order derivative present in this equation is what? d3y by dx square. Can you tell me what is the degree of this? It is 1. This is 1. So I will going to write here 1. Yes, you are perfectly correct. So order is 3 and degree is 1. Similarly, I can have one more equation like say sin x plus cos x plus dy by dx the whole to the power of 5, then d2y by dx square, okay, whole to the power of 2, then d3y by dx cube whole to the power of 4. Can you tell me what is the order of this differential equation?
Order is 3 and degree is 4.
Perfect, you are right. So order will be 3 because that is the highest order, and degree will be 4. You are right. You will not going to look here. This 5 you will not going to look. Why? Because order for this is only 1, dy by dx. So this is the correct answer which you have given me. Okay. Next, I will going to ask you one more question, and that is, tell me what is the order, not order. Okay, fine. Dy by dx plus say sine of dy by dx, okay, is equal to 0. First question what you need to ask is this a polynomial in derivative or not? Okay, so I will say this is not a polynomial in derivative. This is wrong. So if I don't have a polynomial in derivative, I cannot have the degree. Okay, so what is the degree of this particular differential equation? Does not exist. Does not exist. Why is
Sir,
the
आप
why?
polynomial in derivative से क्या कहना चाहते हैं?
बताता हूं मैं, बता रहा हूं. Degree does not exist, right? Why degree does not exist here? Because of this sine function. Within sine function you have dy by dx. So because of this I can say that this is not a polynomial in derivative. Now you will say, sir, why, what is polynomial in derivative? आपने पहले मुझे बताया नहीं. ठीक है, ये देखिए, ये सब polynomial है. Okay, x square y plus xy cube plus x to the power of 5 y square plus xy plus x square plus y to the power of 4. This is all a polynomial, right? So इसकी डिग्री आपको
Yes,
पता है,
sir.
ये 3 है, ये 4 है. अब इसकी जगह अगर आप x की जगह आपने लिख दिया dy by dx, ठीक है, या y की जगह आपने लिख दिया dy by dx, ठीक है, तो क्या होगा? तो आपके पास जो पॉलिनोमियल बनेगा उसे बोलेंगे पॉलिनोमियल्स इन डेरिवेटिव. समझ में आया?
हाँ सर.
पॉलिनोमियल ऑफ डेरिवेटिव समझ में आ गया अभी, राइट? सो तो ये जो है, ये जो इक्वेशन है, दिस यू कैन से पॉलिनोमियल इन डेरिवेटिव. व्हाई? बिकॉज देखो ना, यहाँ पर डेरिवेटिव है, यहाँ भी डेरिवेटिव है,
हाँ
यहाँ भी
सर,
डेरिवेटिव है.
समझे.
दिस इज पॉलिनोमियल इन डेरिवेटिव. सो इन शॉर्ट व्हाट यू कैन से, in short you can assume dy by dx as say x, or you can assume at say y, something, say you will assume at say a or b. Okay, for example, here I am assuming this, here I am assuming dy by dx as what? Say I am assuming this as a. So what will be this? This will be a square the whole square, this will be a cube the 1, this will be a, this will be y plus x is equal to 0. So I will write this a to the power of 4 plus a to the power of say 3 plus a, okay, plus y plus x. So this is what? This is a polynomial in variable a. This is what you can say, now this is a polynomial in variable a. But if a is, if we are replacing this a with what? With dy by dx, then this will be called what? This will be called a polynomial in derivative. It means dy by dx. That's what is the meaning of it. Okay.
Yes, sir, understood.
So whenever you do not have a polynomial in derivative, that time degree does not exist. That's what I'm trying to explain you. Got it?
Yes, sir. And
Okay. So what here it says the degree of differential equation is power. Okay. Degree of differential equation is power of highest order derivative present in the equation. To find the degree of differential equation, we need to have positive integer as a index of each derivative. It means you cannot have like this dy by dx plus sine inverse of dy by dx is equal to 0. This you cannot have. You cannot have inverse. You can have inverse, not a problem. But inside inverse dy by dx, you cannot have. For example, dy by dx plus sine inverse of x is equal to 0. This is differential equation. It is perfectly correct. But this is not differential equation. Why? Only because here you have dy by dx. That's the reason this is not a what we say, this is not a polynomial in derivative. Okay, then you will say, sir, can you give me a few more example where it is not a polynomial or derivative? Yes, I will give you dy by dx plus e to the power of dy by dx is equal to 0. If such kind is there, then also it is not a polynomial in derivative. Then you will say, give me one more example. Okay, so one more example is what? Dy by dx plus say log of dy by dx is equal to 0. This is again does not exist. This is not a polynomial in derivative. So I cannot find the degree of this. Okay, sir, can you say this as polynomial in derivative? Tell me. Can you
yeah,
say
sir.
this?
Can you repeat?
Can you say this as polynomial in derivative?
No, sir.
Yes, you will going to say this as polynomial in derivative. This is what answer you gave is not correct. This is polynomial in derivative. Why? Why this is polynomial in derivative? Because under sine I have only x. If I am replacing this x, if I am replacing this x with derivative dy by dx is equal to 0, then it is not. Understood or not?
हाँ सर समझा.
Okay, similarly, give me one example. Give me, is it a polynomial in derivative or not? E to the power of 5 is equal to 0. Is it a polynomial in derivative or not? Tell me.
Yes, sir. It is.
Yes. Why? Because this is a constant. So it is. Similarly, here dy by dx plus log of say x is equal to 0. Is it a polynomial in derivative?
Yes, sir. It is.
Yes, it is. Because log of x है तो चलेगा, मतलब डेरिवेटिव नहीं होना चाहिए वहां पर. ठीक है, तो यही चीज आपको समझनी जरूरी है. ओके, नाउ नेक्स्ट पॉइंट इज, okay, so here we have solved example example number 1. Find order and degree. Find order and degree of the following differential equation. This is a differential equation. Why? Because this is d2y by dx square, this is dy by dx. I don't have anything sine, cos, or sine of some derivative. I don't have. So this is a differential equation. Okay, and what is its highest order? Highest order is 2, because this is dy by dx. So highest order will be 2. And what is the degree of this? The degree of this is 1. So the degree is 1. Similarly, over here, the highest order is what? d2y by dx cube. And what is the degree of this highest order? It is 2. So degree will be 2 and order will be 3. Similarly, here it is r, dr by dr by d theta plus cos theta is equal to 5. Here again I have a degree of 1. Why? Because I have only one differential equation, this. So order will be 1 and degree of this is 1. So degree is 1. Similarly, here d2y by dx square the whole square plus dy by dx the whole square is equal to e to the power of x. This is a differential equation. Its order is 2 and degree is also 2. Why order is 2? Because highest differential equation is differential or highest derivative is dy by dx square, and the order of this is 2. So order is 2 and degree of this order is also 2. Now let me explain you 5 and 6 also. Okay, just a minute. 5 and 6 also I will go. Fine. So we need to find the order and derivative of question number 5. What it says, dy by dx is equal to 3xy dy by dx is equal to cos x. So I should not write, means I in my equation I should never have anything in denominator. Okay, this I should not have in denominator. Okay, this particular term dy by dx should never have in denominator. So what I'll do, I will going to multiply by dy by dx on both the sides. So here what I'll get dy by dx the whole square, and this dy by dx, this dy by dx will get cancelled, and I will get 3xy is equal to cos x. Then again dy by dx I will going to get. Now this is the differential equation, right? This is the differential equation, and you can observe that the order of this is 2. Okay, order 1 minute, dy order is 1, not 2. Order is 1, highest order is 1, and what is the degree? Degree is 2. Because of this, this will be your degree, and order is 1.
सर आप आपने एलसीएम निकाला है ना इधर?
I have not taken the LCM. ठीक है, आपको LCM समझना है तो LCM समझ लो. But I have
नहीं समझा, आपने थ्रू आउट मल्टीप्लाई किया. हाँ समझा.
हाँ, तो डिनोमिनेटर में हम we never write in polynomial. See, we have to convert everything in polynomial and derivative. Okay, we never, this is not a polynomial. For example, let me explain you. For example, x plus 2 by x is equal to say 5. This is not a polynomial. Okay, so we have to convert this polynomial by what? By multiplying by x on both the sides. So when we multiply by x on both the sides, what we get? We'll get x square plus 2 is equal to 5x. Now this is the polynomial. This was not the polynomial. Why? Because the degree of x is -1 over here. Why? Because this I can even write this as x plus 2, x to the power of -1 is equal to 5. So this power, okay, this -1 should not come. If -1 is coming, I will not going to call this as polynomial. Okay, so to have this polynomial, I have to multiply by x on both the sides to convert this into polynomial. Same thing I did here. Dy by dx should never come in denominator. So I multiply by dy by dx. Okay. And then you need to find what is the degree and the what is the order. Hope you have understood this now, right? Okay. So in question number 6 also, okay, we cannot have anything in square root. We cannot have a square root of 1 plus 1 upon x square is equal to x to the power of say 5 by 2. Okay, this I cannot called as a polynomial. Okay, so I have to convert this. I have to convert this into what? I have to convert this into polynomial. For that, what to do? I will going to squaring on both the sides. I will going to square on both the sides. So when I do squaring on both the sides, this will become 1 upon 1 by x square, and this will become x to the power of 5. This 2 and 2 will get cancelled. Now here again you see x square in denominator. This is again not a polynomial. So I will going to do what? I will go to multiply by x square on both the sides. So I will get here x square plus 1 is equal to x to the power of 7. Okay, x to the power of 7. This is the polynomial. Okay, this I can call as a polynomial. So same thing. Sir. So same thing you need to do here. You will going to square on both the sides. So when you do square on both the sides, you will get 1 upon say y1. Okay, y1 is what? Derivative. One order derivative is equal to, this is what? Y2 whole to the power of 3 by 2 into 2. Why? Because I did squaring. So this 2 and 2 will get cancelled, and finally I will get here y2 the whole cube. So I am writing here cube only. Now what to do? Denominator I should not get derivative. Okay, so what I'll do? I will going to multiply by what? I will going to multiply by y1 the whole square on both the sides. So I will get here y1 the whole square. Here I will get 1, and here I will get y2 the whole cube and y1 the whole square. Now here, what is the highest degree? Not highest degree, highest order. So this is 2 time derivative, na? So highest order will be 2. And what is the degree? Degree will be 3. This 3 is coming from here. Understood?